For the last couple of days, what we've been doing is taking a look at the commands that you use when you manipulate strings, anything with quotes on them. And you can have letters inside of quotes, or you can have numbers inside of quotes. Today we're finally going to get to see how this really applies to the real world. And like I mentioned before, this is used in cryptography when you encode things and decode them. And what we're going to look at it in the next couple of examples is what we call product validations. You go to a store and you give them your visa. How do they know it's a valid visa? You go to a job and you give them your social insurance number. How do they know that's a valid social insurance number? So we're going to do all kinds of neat things like that today. Now, before we get to that, we want to review, and we'll go back to this question that I have on the screen right now. We finished up our last lesson by taking a look at string accumulators, a really important idea that we're going to need today, putting things together in different orders, backwards, forwards, or whatever. And we did this particular problem together, given a number, print it forwards and backwards, and then add them together. And what I want to do with you right now is take up these two homework questions. The first one is to enter two 6-digit numbers and then take the second, fourth, and sixth digits and make new numbers out of those and add them together. And then question number 3 is to validate a driver's license number, and supposedly if you add up all the digits, they have to be divisible by 7. Okay, so let's take up question problem 2. And you know the basic technique I use when I do these questions. If you're not sure of yourself, copy and paste the question that I did before, and then obviously modify it to suit the question. So in this particular one, we're looking for 2 numbers instead of 1. So we're going to ask for a number, and then we're going to make a new number 1, and then we're going to ask for another number and make a new number 2. So I'm going to call this one number 1, and we're going to call this new number 1. Okay, and then we're going to basically do this a line again, but we're going to do it for number 2. Okay, so this is going to be number 2 and number 2. Alright, so like I said, we're going to ask for 2 numbers this time. So we're going to ask for one of them there, and I'm going to copy and paste. Okay, and we're going to ask for a second one, obviously. Okay, and then we'll change that one to number 2. Okay, so we're basically ready. Now what we want to do is we're going to make new numbers out of supposedly the second, fourth, and sixth digits. Now you remember how things go? This digit right here, which is the first one, is actually called like 0. And this second one, which we want to use, is actually 1. So we don't really want to go 2, 4, 6. We want to go 1, 3, 5. So that's what's going to be a little bit challenging. You always got to get it in your mind that it's not starting at 0, it's starting at, you know, whatever you consider to be the particular point you're after. So in this particular question, we're going to rub this out, and we're going to start from 1, and we're going to go to 5 by 2s. Okay, and we're going to make a new number 1. So we're going to type in the word new number 1 plus equals, okay, and then we're going to pull it apart from number 1. Okay, so that's going to be the first part. Now this is yelling at me because I got an extra space there. I think we're ready. Okay, and the second one's going to be exactly the same. So you know the basic idea. You always just try to maximize what you've already done. So there's going to be the second one. Same thing. It's going to go 2, 4, 6, but really that's really 1, 3, 5. And it's new number 2 and 2. Okay, and this pulls out each one at that spot. Alright, and the last part then is after you've created a new number 1 and a new number 2, you take this new number 1, which has quotes on it, take them off, take the new number 2, which has quotes on it, take them off, and then you can add them mathematically. And then you print out the result. Here is the new number 1. Here is the new number 2, and this last one, which was mathematically worked out, has now had quotes put on it, so it'll print out nice. Okay, let's take a look at how it runs. So let's pretend the first number is 1, 2, 3, 4, 5, 6, and the second number is 6, 5, 4, 3, 2, 1. Okay, so 2, 4, 6 would be the first one, 5, 3, 1 would be the second one. You add them together and you get 7, 7, 7. So that's perfect. Alright, now the second homework question. It basically says, consider that a driver's registration number has this format. I want you to write a program which checks the validity of the number. If the number is valid, the digits when totaled must be divisible evenly by 7. Okay, so again, like I did last time, when I'm not sure what I want to do, I'm just going to copy and paste one of the answers I've done and put it into the next question. So here it is, pasted in again. So this time I'm going to ask the person for their license number, so to speak, and I don't really need this part about reversing. What I do need is something about a total. So I'm going to say int total, and I'm going to set it to 0 there. I know I've got something down here, but it's going to be different for this question. So I'm still going to ask the person to give me their, driver's license number, whatever you want to call it. And in this one, what I'm basically going to do is add up all the little parts of their number. So I'm going to start at 0, because remember how strings start at 0. So we'll put a 0 there. And we're going to go to... Now don't pretend you know how many letters or numbers there are in this thing. Let the computer work it out. So we're going to go to less than number.length. Okay, and you always go to less than, because like if there's a 10-digit number, it actually goes from 0 to 9. Remember, because we start at 9, so you're always one less than what you think. So that's going to go from the beginning of the license number to the end. And like I said, we're not using reverse in this one. We're going to total stuff up. So we're going to go total equals total plus. Now watch this. Int.parse. So what this does, and I'm going to put another bracket at the very end, is, and I'm going to really accentuate this for a second. Okay. What we're doing is we're pulling apart one thing at a time. So that big long number, we're going to pull out the first digit, then take the quotes off of it, add it up. Second digit, third digit, and keep going like that, right? At the end, we'll have a total. And if you actually typed in that exact number, okay, we'd have to divide that by 7, okay? And we'll see if it goes in evenly. So let's go like this. We're going to rub this out because we don't need this now. This part's different for this question. Okay, so we're at the last stage where we're going to figure out, is this answer divisible by 7? Like 70, if you divided it by 7, it would go in 10 times and nothing left over, right? So how do you tell the computer, is there anything left over? You go like this. You go if total %7 double equals 0, and that tells the computer there's nothing left over. So that percent stuff does leftovers, remainders, right? Then you go message box dot show number is valid, else okay, and message box dot show number is invalid. Okay, so that's the basic program, and that's the answer to the second question. Okay, now we kick it up another notch. Now we get even more realistic. And what this one is from an old American Express card scheme. And basically what they used to do, it's not true now, they would take the account number of this credit card, and usually the last or the first digit is what's called the check digit. So what we're going to do in a few minutes is going to be based on whatever our answer is. It's got to have to match maybe that first number 8 or that last number 4. So you'll see in a second. So what they do is they don't touch, in this particular one, the 8. Leave that alone. And they grab every other digit and they pull them apart and they double everything. Okay, and then they get this magic answer 84. Okay, now what do you do with this 84? So after you've got that 84, somehow you've got to take the 8 in the very front of it and see if it matches that 8. If it does, it's a valid number. Okay, so now we're getting truer and truer examples of what happens in actuality. Okay, so let's drop this down. Now this program on your hard drive is called Credit Card. All right, it's already done. And I want to go through the program with you to make sure you understand it, and then we'll try a sample example. I should definitely print this out after. I've got some comments up here to remind you exactly how it works again. So in this example, we're going to ask the person for a credit card number, and then we're going to add up the 9 digits. But you're going, sir, there's 10. But remember, we don't touch the first one. Okay, so we're going to do those ones only. Okay, so you ask the person to type in a credit card. Now on the test, you wouldn't have to do this dummy proofing, but this is kind of like basically saying, listen, buddy, type in a 10-digit number, and if you don't, I'm going to keep asking you. Okay, then you've got this loop, which is almost like the one we just did 2 seconds ago. Okay, you're going to have a loop pull apart every single thing, and then parse it, and you got to make sure you watch. Then outside of the bracket, you times it by 2. Don't put that times in 2 in there because it's still a string. It's after you parse it, you times it by 2, and this is going to give you like a grand total. Now, if you remember the question, what is this grand total going to come out to? It's going to come out to 84. So now we've got to figure out a way to just grab the 8 in 84. How do you grab just the 8 in 84? Well, this is one of the ways. What you do is you take this 84, because that thing right there, total 9-digit, is the number 84. The number, remember, 84. So now you got to put quotes on it. Okay, that puts quotes on it. And now you got to grab the 8. How do you grab the 8? The 8 is the first digit. But remember, strings start at 0. Okay, so keep focused. Okay, so this is going to grab the 8. And how many things do you want to grab? Do you want to grab 8 and the other numbers? No, you just want to grab the 8. So that second number means how many you want to grab. Great. So now this has in its brain the 8 of the 84. Now I got to see if that matches the 8 of the original number. How do you say the 8 of the original number? This right here. The original number was credit card. And you just want to grab the very first digit and grab 1. And you're going, sir, how come you didn't do that to string here? Because it was already a string. Remember when you asked the person for the credit card? It's already a string. Okay? It was this one that you did math to that you had to make into a string first. Okay, and now the moment of truth. Does the first digit of that total, 84, equal the first digit of that big, long American Express card? Yes, it does. It's valid. No, it isn't. It isn't valid. All right, the Schneider code example, which is the second one we're going to look at, is a little bit different. All right, what it does is it's a 5-digit number, and what they do is they start off with the first digit and they times it by 5, and the second one by 4, 3, and 2 to get an answer. Now that's different. We were doubling all the other ones, and in this one they leave the last digit alone. Okay, and then they're going to do this thing where they divide it by 11, keep the remainder of 9, then go 11 minus 9, you get 2. Whoa, 2 matches 2. We'll worry about that in a second. So here we go. So what we're going to do first is I copy and pasted. So we ask for a product code, and we're going to work out a total. Here's the tricky part. You know how we were timesing by 2 in the last question? Well, now it's not going to be 2. It's going to be 5 at the beginning. But you know what? After it's 5, all right, because we're going to have the loop go from 0, 1, 2, 3. So the 4 things. So 0 to 3, that's 4 things. You're going to have to make the computer tell itself to go down by 1, because the next time you times it, it's going to be 4. So that's how you tell the computer to start at 5 and times that by 5, and then go 4, 3, and 2. Okay, so far so good. Next, we have to tell the computer, take my answer, divide it by 11, but only keep the leftover, and then do the 11 minus the leftover. Okay, so let's see how we do that. So we're going to invent a new variable called rem for my remainder, and we're going to take this total we worked out, and we're only going to keep the remainder when we divide it by 11. Okay, so that's the next step. And then we're going to do this thing, and I'll call it check, and it's going to be 11 minus remainder. Now this part's getting a bit tricky. So we're almost done. So we've got this number 2, and we've got to see if it matches that. Now we obviously can see they match. How you tell the computer to do that? Well, see, this is a number 2, and we're going to pull apart this string 2, but we're going to have to take the quotes off of it. So here's how you do that. So we've done the remainder, then we did the 11 minus the remainder to get this magic 2, and now this is the 2, that's a number, and this is how you grab the very last digit in the other one, right? So 0, 1, 2, 3, 4, 5 would be the 4th digit, not the 5th one, and when they equal each other, you say they're valid. And that's how it's done.